So this video will show off the functionality and key features of my computer science AA. And essentially, my client is a programmer who works with banks in terms of data manipulation. And so my solution to his problem was to show off the power of database manipulation, since he felt many of potential customers didn't recognize the benefits that it could bring to their businesses. So as you can kind of see, this animation has boats move from their starting point ports to their destination ports. And every 4 seconds, the data store this system is working on updates. Essentially, the system runs on an immutable data store, which means that rather than being able to change any of the values here, a new state has to be generated every time a dispatch is sent to update the data store. And so what that means is every 4 seconds, those dispatches are sent, and that affects the position of these objects, because each of these objects have a abstract object related to them in the data store. And with each, as you can see in the background here, every time those 4 seconds go up and the update function is called, there's a 50% chance that the win matrix will change via Perlin noise. And boats update their position in the database after tweening if needed during this time, and if they've reached their port, they may reset back to their original port. And the speed of the boats is based off of the initial the win strength of the cell it starts tweening from. So to evaluate my success criteria, one of them was whether it runs and opens on a modern laptop using Chrome. So I'm using a Lenovo Legion, which I was purchased a year ago and would be considered an above average laptop. And as you can see, it runs fine. Now, the second success criteria feeds into this, and it's whether the animation runs smoothly. And as you can see, it runs smoothly enough. But if you look into performance here, every time the win matrix updates, there's these little dips in performance, and it has a slightly jank effect. It's not horrible, and so there is a semi-failure in that success criteria, but it's not too bad. Now, the third success criteria is whether boats will move from their original port to their destination and then return back once they've reached their destination. As you've been seeing in the background, that has been a success. And as you can also see, the wind flow fields can be generated and regenerated. And so every time there's that 50% chance when it updates every 4 seconds. And you'll see that the Perlin noise map here changes the angles of the wind. And so that can be seen to be a success. It's also visible within the code here, demonstrates that. The next success criteria was whether the client could pick up from where I finish. And as you can see here, there's been extensive documentation on the installation process if you were to develop it. And I also published all of this on GitHub. So a simple git pull, as well as the Bower library was implemented, so that if you were just to put into your terminal npm install, it should install all dependencies. And so with that good code documentation and the aforementioned facts, I believe that this criteria is a success. The next success criteria is whether grid-based coordinates can interact with the game world. So again, you've been seeing that in this example here. Clearly the program wouldn't run otherwise, but the code itself is found here. So mesh coord to scene, which it takes in a mesh coordinate, which is like the matrix x and y row column values, and it returns a phasor point, which is the game API's game coordinates. So the seventh success criteria is whether the immutable database can be accessed and manipulated easily. The access, you can see, is quite straightforward. A lot of objects here are calling their counterparts within the database, a lot of these game objects, and you can see it's as simple as store, which is defined within client app, and is the data store .getState.getIn, and it just gets its respective object within the set of all of those similar objects. The manipulation, there's plenty of dispatches here that show that that's also quite easy to do. And then finally, does the database match what is on screen? And as you can see, that this here, if I was to move one of these values so that the port, for example, here, instead of being in row 1, column 17, I could move it to row 0, column 0. And you'll see when I reopen this and it refreshes that it's now appeared here. So that's a good demonstration of that in effect. And so finally, it's good to address the future development. So one of the things you may have noticed is that the one thing about database matching what's on screen is the boat rotations themselves, and they have not been implemented in terms of actually changing the physical position through a dispatch. And so that's a future system that could be added and extended onto it. Additionally, Neo4j graph databases were initially set up in this project. And so if a future graph from crowdsourced information, unfortunately could not be found at the time, was to be shared with whoever was running this project, that could be implemented. And on top of that, using a graph database, you could actually have the boats move from one position to another in the fastest possible way, considering the different wind speeds. The jerk that was mentioned before could be fixed by having a renderer, within the client app only render what was affected by a dispatch, because one of the issues with the jerk is that everything on the screen, as you can see, is changing at the same time, and so doing that should help alleviate some of that. Another thing is, as you can see in this example, the boats currently have no way to avoid land, and so that's a future feature that could be added. Additionally, different lakes or buttons to have the people that come onto my client's website interact with the actual immutable database and then affect the immutable data store and then affect what's visually going on screen could help sort of reinforce the points that are trying to be solved and come across through the solution. And that concludes the video on my computer science IA. Thank you.